photograph, you probably have a device in your pocket which has a little camera in it. And there's a little lens, and when I open a shutter, that lens focuses an image on a sensor, and the sensor records the image that was created by the lens. And that's basically how a camera works, is it uses a lens to make an image on a sensor. But we can see how a camera works much more clearly if we have something which is bigger. And so I've got this old school camera right here. I'm going to use this camera to make an image of this object right here. Now I'll take this camera and I'll put it right back here. And let's look at how the optics work. In the front of the camera, there's a lens. And if I turn it around, you can see this. There's clearly a lens that's in the front. And this lens is a certain distance from where the image is going to appear. In the back of the camera, if I open it up, there's an opening, and right here we'd have a piece of film, and that's a piece of plastic with an emulsion on it that's light sensitive, and so the image would be recorded right here. We're not going to put in film. Instead, what I'm going to do is I'm going to put in a little piece of paper, and now I can make an image on this piece of paper. And what I can do is I can open up the shutter of the camera, and I have an object, I have a lens, and I'll have an image on the piece of film. But if you look at this, this is not a particularly crisp image. The way I make the image appear in focus is to change the distance between the lens and the screen. I'm going to change the image distance, and I can do that by screwing the barrel of the lens. The lens moves further from the piece of paper, and at just the right distance, I get a nice crisp image of the object. And that's how you focus a camera. I change the distance between the lens and the film, or between the lens and the sensor, and that's how I bring it into nice, sharp focus. Now, something which has an optical system that's exactly like that of the camera is your eye. Your eye has a lens in front, and it's got a screen in back, and the screen is light sensitive. It's your retina. And we have a model of the eye that we can use to make an image of this object right here. So let's bring the eyeball in here, and we'll use it to make an image of this question mark. Okay. And for this segment, we'll need to have the lights a little bit dim. Okay, and now you can see I have an object, I have a lens in the front of the eye, and I have a screen in the back of the eye. This represents your retina. This is the lens of your eye. Here's something that you're looking at. Here is your retina, and I get an image on the screen. But the image isn't in focus. To get the image in focus, I need to adjust the optical system. Well, in a camera, I change the distance between the lens and the screen. So I could make the image be in focus by doing this, by changing the shape of your eyeball, but in fact that's not what you do. You don't change the shape of your eyeball, you change the shape of your lens. And so we represent that in this model by using a syringe to push water into the lens, and we push water into the lens, we change its shape, and we can bring the image into a nice crisp focus. And now my object makes a very, very nice image on the screen. And so if you were looking at something, it would be in focus, you'd be seeing a nice crisp image of it. But now think about this. If I take the object and I move it closer, the image is now out of focus. So I've decreased the object distance. The image distance is fixed. That's the distance from the lens to your retina. So here's a question. How can I adjust the focal length of the lens in the eye in order to bring the image back into focus? We'll give you some choices. Let's think back to the equation that we had in Chapter 18 for lenses and images. And we have 1 over the focal length of the lens is 1 over the image distance plus 1 over the object distance. But the 1 over the image distance is a constant because the image distance is the length of your eyeball. So if the object distance has decreased, the focal length has to decrease as well. And so I have to take the lens and I have to decrease the focal length. And for this lens, I'll do that by making it chubbier. I'm going to take the syringe, I'm going to squeeze it so more water goes into the lens. And when I squeeze it and make more water go into the lens, I can bring the image into a nice, crisp focus again. And I made it chubbier, I've decreased the focal length. Well, in chapter 19, usually instead of talking about focal length, we talk about the power of an optical system. And the power of an optical system is 1 over the focal length. The power in diopters is 1 over the focal length in meters. And using power helps us this way. If I take 2 different optical elements and I put them next to each other, the total power is just the sum of the individual powers. And here's how we use this. If I take this object and move it farther away, the image is back out of focus. Now, in fact, my eyes work like this. I can look at close-up objects, and they're in a nice, sharp focus. But when I look at distant objects, they're not. And so what I do is I add another optical element to the system. I add another lens in front of my eye, and the power of this lens adds to the power of the lens in my eye to make a total optical system that brings the image into focus. And we can do that here. We can do that here. Now here's a question. I've taken this object, I've moved it farther away, it's out of focus. If we assume that the lens can't adjust to bring that image back into focus, I've made the object distance bigger, I need to add another lens to this system in order to bring it back into focus. Would I have to add a converging lens or a diverging lens? We'll give you some choices. The image distance is fixed. The object distance is getting bigger. And if the object distance is getting bigger, the focal length has to increase. But the focal length increases means the power of the optical system decreases. But we're assuming that I can't decrease it beyond a certain point. I've got to decrease it further. And what that means is I have to add to it something with a negative power. I have to add a diverging lens to the system. And if I take a diverging lens and I put it in the system, what happens is this. It takes the image on the screen and brings it back into a nice, sharp focus. So fuzzy image, because I can't make the power of the optical system small enough, if I bring in a diverging lens, I bring it back into a nice, crisp focus. And this is a situation that many of you have. Many of you are nearsighted. You can look at close objects. You can't look at distant objects and have them be in focus. And so you use diverging lenses either in glasses or in contacts. And that's a situation that many people who are watching this video will experience. And so we can use a lens to correct an optical defect. Now, we are using a lens to help improve your vision. And that's our first example of an optical instrument that we can use to help you get a crisper view of the world. But there's other optical instruments which we'll take a look at as well. And we'll do that in the next segment.